Alright, let's go. Number 10, the measurement problem. In 1927, at the 5th Solvay Conference in Brussels, the greatest physicists alive gathered to debate a finding so disturbing that Albert Einstein refused to accept it for the rest of his life. Werner Heisenberg, Niels Bohr, and Max Planck sat in the same room, arguing over data that suggested something deeply wrong about the nature of reality. Quantum mechanics had just revealed that subatomic particles don't have definite positions, speeds, or properties until the exact moment they are measured. Not that we can't detect those properties, that they don't exist until something looks. Before this discovery, the assumption was simple and reasonable. The physical world existed independently of anyone observing it. A particle was somewhere specific, moving at a specific speed, whether or not a scientist was watching. This was the intuitive common sense picture of reality that had underpinned physics since Newton. The universe, it was assumed, did not require an audience. Then came the anomaly. The double-slit experiment, refined and formalized through the 1920s, showed that particles fired at a barrier with two openings behave like waves when no one is watching, spreading through both slits simultaneously and creating an interference pattern on the far side. The moment a detector is placed to observe which slit the particle passes through, the interference pattern vanishes. The particle suddenly behaves like a solid object passing through one slit only. The act of observation physically changes what happens, not the instrument, the observation itself. John Wheeler deepened the horror in 1978 with his delayed choice experiment, later confirmed in the lab by Carroll Alley's team in 1984. Wheeler showed that a particle's past behavior changes depending on whether we decide to measure it. Even after it has already traveled, the choice made in the present reaches backward and alters what the particle did in the past. Heisenberg's uncertainty principle formalized the boundary. You cannot simultaneously know a particle's position and momentum, not because our tools are imprecise, but because those two properties cannot both exist at the same time. Niels Bohr's Copenhagen interpretation, still the dominant framework in physics today, states plainly that quantum objects exist in superposition, a blur of all possible states until observation forces them into one. If particles only become definite when observed, what was the universe doing for the 13.8 billion years before any conscious observer existed to look at it? The most literal reading of quantum mechanics suggests the entire cosmos was a superposition of possibilities, unresolved and unreal until something looked. The universe may not have needed the Big Bang to begin. It may have needed a witness.